Hey everybody, I got a little bit of a treat for you today. This is a really cool tool. It is not a black screen, it's Nullschool. Alright, this right here is a map of what seems to be the current conditions of Earth in several different facets. Now, right here, I believe it's showing, what is it showing? What are we on? We're on air mode. We're at surface air. Overlay is wind. Okay, so I am not sure what they mean by air, but I don't know if it's maybe a measure of air quality or something. There's some sort of event going on over here. A little blip. A little blippy blip there. Yeah, it's a weird one. What is that? What is that? 1 second. Why is there a... That's at... Okay. 1837, 127.08. Alright, so if I just go to like weather.com or something, or if I take a look at the Pacific radar, what is that? That is so weird. See, this is what's cool, is that you can get real-time... That's Pacific, California. You know, I can pan over, though. Maybe. Maybe there's not a weather radar out there. Yeah, there is. It's a real thing. It's happening right now. Let's animate this. Can I animate this? What's going on? Well, that didn't work. Oh, there we go. Okay, now it's working. Yeah, so... do this to fix your car scratch? What did that guy do to get a car scratch like that? Jeez. I'm gonna guess it involves a girlfriend and then a girlfriend's sister. Cool. Yeah, so Nullschool. If you take a look at this, you can see all these different lines here representing airspeed and wind direction, of course. I'm guessing that this air is probably... Oh yeah, of course. It's air pressure, almost certainly. I don't know why I was having confusion earlier. But yeah, this is Nullschool. It tells you all kinds of really cool things about weather, about different conditions on the Earth. We're just going to take a look through all these different settings and see what we're looking at, right? So we have mode. Here we go. Here's ocean. Oh, okay. So the mode air is all these other different things, right? So let's stick to air for a second. So let's just pop up a few. Let's pop up above the surface here. Let's go to, what's this, 1,000? Okay. So we're going to go back down to Earth here. Yeah, what is this? Must be the 500 must be the jet stream. What is that? Jet stream altitude. The jet stream. It is 9 to 12 kilometers or 30. All right, so 9 to 12 kilometers. Oh, the strongest ones are at 9 to 12. Okay. You also have subtropical jets at 10 to 16. This is really cool. By the way, if you're a homeschool student or if you're just like to learn, this is how you get there. If you have some data, what you want to see is some data, and then you want to see the data that doesn't make sense to you. Like, what is going on here at 500? Well, this is H pascals. Oh, okay. So they're relating. Got it. Okay. Hectopascals. So pressure can be a measure of altitude. So HPA to altitude, because as you go up, if you go up in altitude, the pressure will drop. There's just less air. So I want to do enter your. Okay, what was that? 500? I don't know. I don't know what's going on. Inches of mercury. Why does it say uncorrected station pressure here? There's got to be a better conversion. Pressure altitude calculator. Okay, so weird. Station pressure. Huh. Well, I don't understand this, so 1,000 inches of mercury does not seem right. Yeah. Millibars. Okay, maybe this is millibars. I mean, that makes some sense. 300 feet in the air is not that high, but let's go ahead and do 500 and see if that actually gets us into the jet stream. It looks like it's getting close. So that's about 5.6 kilometers. That's looking pretty close, according to Wikipedia, which is, by the way, a decent source to get you started. I mean, it has references. You're not supposed to believe any of this stuff. You're just supposed to read it and then see if you can make sense of it. You're supposed to be making sense of things, not believing stuff you read. That's for... Oh, okay. This is the real jet stream. Yeah. So let me punch 250 in here. So that would be 10 kilometers, which is right where. Yeah, that's right where this thing, the Wikipedia page at least tells us the jet stream starts. Right. So 10 to 16 kilometers. 9 to 12 is where the polar jets are. Strongest polar jets are at this height, this altitude. And I'm guessing we're going to get stronger jets as we go. Oh, no. All right. Oh, wait a second. What is... Holy smokes. So what is 10? What is 10 hectopascals? Are those actually hectopascals? Oh, I got that right. Yes, what is that? Hectopascals. Yeah, okay. I was just saying something without knowing 100% if it was true or not. That's a bad habit of mine. I think it's a bad habit of everyone. Of course, if you didn't make assumptions in life, you would be completely crippled. You have to accept some things as true. Right? I'm going to turn this phone off. It's driving me nuts. It's not even important. Oh, shoot. Actually, it kind of is. All right, so we got our air, we have wind, temperature. Of course, it's going to get warmer as we get closer to the surface. See, the brighter, the more red it gets along this scale here, the more warm it gets. And here's surface. Pretty hot over the Amazon right now. Not a lot of temperature variation with the location of that storm. How's China doing? Now, this is the really cool part, though. Yeah, there's relative humidity as well. I don't know what WPD is. Oh, wait, here we go. Instantaneous wind power delivery. Incredible. That overlay doesn't seem to be working. 3-hour precipitation accumulation. All right, so these are all the places where it's precipitating in the last 3 hours. Convective available potential energy from surface. Not sure what that is. Convective. Convective tells me that it has to do with heat traveling in the air. So probably surface heat to potential energy as rising up, I guess. I mean, I'm seeing, when I click here and here, I see some correlation between that. Interesting. The really cool part, though, is the chemicals. So here it is. This is a carbon monoxide. And this is the surface concentration of carbon monoxide. As you can see, California is a big problem. There's areas down in the Amazon as well. You're going to see less. You're going to see other countries that don't have tight restrictions on carbon monoxide production also having an issue with this. So whatever this is right here, this is a big producer of carbon monoxide. If I were to punch this coordinate in to Google Maps, let's go find that out. So a cool activity that you can do with your students is go and do some sleuthing and find out what are the different sources of carbon monoxide. You know, this, that, and the other. This is in the Ukraine. I don't know how to read Russian. So somewhere out in the middle of a field in the Ukraine, out in Oblast, is producing a lot of carbon monoxide. I don't know how accurate the coordinate system on Nullschool is. What is going on over there? Huh. That's a mystery. I mean, what isn't a mystery is all this. I mean, come on now. You know, this is China. China. Here's CO2 emissions. This is CO2 surface concentration. You got a lot of India. You got a lot of Africa, the middle area of Africa. I think this is the Veldt. It's kind of bordering on the Congo. And the jungles there. You also get a lot over in the Amazon as well. Oh wait, no, I'm sorry. Those are voids. Yeah. So all the forested areas have a void. Yeah, sorry, I was reading the scale wrong. That is a void of carbon dioxide. So the lighter color you get, the more carbon dioxide is being emitted. You get a lot towards this Russia and Northern Europe, middle and Northern Europe, and a lot of concentration in California. What is California doing that they're producing this much pollution? I thought they were supposed to be like really green and stuff. But you guys are blowing it out. Here's sulfur, SO2, sulfur dioxide. What is this? SM means surface mass. So I guess this is just accumulated. I don't know what produces SO2. Maybe it's a pollutant in manufacturing. Not sure. There's pockmarks of them down here though in Brazil, so that's interesting. All the way up the Andes Mountains. I believe that's Chile. Yeah, I mean I know Brazil has regulations that say that you have to make stuff in Brazil, so that way they have a kind of a homegrown manufacturing base. Which is not a bad tactic. Huh. Check this out. You get streams of SO2 between these locations here in Hawaii. That tells me that this is probably done by air travel. Yeah, look at this. You can see the jet routes. That's incredible. And of course, areas where you have vortices and storms will start to accumulate. This might be a regular wind. If I take a look at the air speed in the jet stream, like if you're a jet, I'm imagining it flies up in the jet stream. So you get a couple of concentrators right here. I'm not seeing a massive concentration of sulfur dioxide right there. But if I go over here and I left my mark there, it looks like it should be blasting it away. You know, it should be spreading it out. So I wonder if that's not the... Yeah, let's take a look. Yeah, I don't see any major vortex action there. Oh, wait. No, it looks like this speed, whatever 850 hectopascals is, that's where this sulfur dioxide is concentrating. That's incredible. About 1.5 kilometers above surface level. So it must be settling down and have a certain... You know how certain things will float a certain amount depending on what liquid they're in? You know, some things will sink in oil, but they're float in water, or vice versa. I believe I think it's a Galileo thermometer works on that principle. Yeah. So all right. So what's going on in the ocean? Here's the ocean waves. So you see a lot of waves around where that storm was, and you can get a really cool idea of what's going on here. You get currents, so you can see where the currents are going. This is peak wave period plus ocean currents at surface. That's what the scale is. Okay. So I can animate the waves and then overlay the current. I can also overlay the waves. Yeah, look at that. That's incredible. Currents are more interesting to me though. That's what's going to move material around. So you see a lot of equatorial currents. And they're all going in one direction. Let's see if that's a global phenomenon. Oh, look, it just slams into Indonesia and then has all these major wave parts. It's probably why Indonesia gets so many monsoons. I don't know. You see it also slams into Africa and doesn't quite know what to do. Now, notice how all of these are going from east to west with some exceptions. Like this looks like it's going the other direction. I mean, there's going to be some backwash, so I guess that kind of makes some sense. What I'm getting at is this might be I think it's the rotation of the Earth that causes this. But the thing is, water has to fill back in. So probably when it's hitting Africa, it's having to, fill back in. It looks like it's going all the way around to the other side of... Yeah, it looks like it's creeping its way back around Australia, and then it just sort of dissipates. I don't know if it's dissipating in the... I don't know if this is reef activity or what's going on, why it's dissipating. It doesn't explain why this pattern is seen constantly. That's pretty incredible. Look at all these squiggly lines. I want to describe these as squiggly. Yeah, very cool. There's the Galapagos, whatever you want to pronounce them as. I've never heard anyone say it like that. Doesn't mean it's not right. SST, what is this? Sea surface temperature. So very cool, very cool. I don't see any correspondence here with the the storms that I was seeing. Let's see. Yeah, it looks like the ocean is heating up a little bit, but the fact that it's getting interrupted here means that it can't cool down. I don't know if its ability to cool down depends on its ability to move. Oh, look at this. It actually, no, it has an immediate recirculation. So you have these currents up above. Oops. These currents up above recirculate right there. So, I mean, this is the fold point, right? This is where it's folding back in on itself. And it doesn't have a lot of directions to go to dissipate that. So it might be just concentrating temperature. Very interesting. Yeah, you can go through here. There's particulates as well. Particulates. I'm not familiar. All right, so there's dust extinction, aerosol, optical thickness 5. All right. I have to Google all of those things. I'm sure these particulates aren't good, but oh, this is just like dust in the air. It seems to be China, India, whatever's happening in Oblast over here. I don't know what's going on there. Over in Norway. California and the Amazon all seem to be major contenders for whatever all these different things are. These are different particulates of different sizes. Okay, you see a lot more of thicker dust. Now, thicker dust is going to be easier for your respiratory system to filter out through the mucuses in through the mucous membrane that you have. I don't know if you guys know this, but all the mucus you have in your system is entirely a filtration system. It's like a wet filter. Particulates will just run into it. That's why if you're out and it's really dusty or there's a lot of pollen, you're going to have to run through it a lot more. Your body will start rejecting a lot of it and creating a lot of it. Just sort of blast it out. Blast out all that stuff. Was SO4, sulfur sulfate, aerosol thing. Yeah. So different sulfates. You could go through it. This could be a huge project. Oh, nice. There's an aurora map. That's dope. This will tell you which live cams to tune into if you want to see auroras. Yeah. This is cool stuff. I hope you guys enjoy it. There's a lot to explore here. Just a lot to explore. Total precipitable water. Yes, this is potential. It's precipitable, not precipitated. So it might not have come down yet. This kind of tells you what's going on here. Notice how these kind of follow the waves. Or do the waves follow it? Depends on your perspective. Actually, depends on cause and effect, which I don't know. Yeah, that's incredible. I hope you guys enjoy it. Nullschool is really cool. And if you want to make a project or make an animation, I think you can do a video capture on your computer fairly easily. And you can actually make animated GIFs of different things and put them in your presentations. You can put them in your research projects. You can go to other times, I think, in this. I don't know how to do that offhand. But there is a way to like go in the Wayback Machine and see like previous times. So you could probably see the derecho or something coming through Iowa, which caused lots of crop failures there. I hope you guys enjoy this. I hope it was enlightening to you. And I wish you luck and have some fun. If you like videos like this, please hit the like button and subscribe for more videos. I always love to share the information that I have. And I also like to make a nice, friendly atmosphere for learning. Sorry, I just noticed that there's the controls. There's the time, I think, right there. So you can go to a different date. But you guys go explore that on your own. This has been really fun. I hope you guys have a good day, and I'll see you later. As soon as I find my stop button.